Okay, what do you got? 200-gallon tank?
A 200-gallon tank initially contained 100-gallon.
Hang on. 200. Wait. 200-gallon tank.
Yes.
Okay, initially contains
100 gallons of water with 20 pounds of salt.
Okay.
A salt solution with a quarter pound of salt per gallon.
Hang on, is flowing in or out?
Is added to the tank.
Okay, so I'm adding quarter pound per what?
A quarter pound of salt at 4 gallons per minute.
Wait, quarter pound of salt per what?
Quarter pound of salt per gallon
Got it.
added to the tank at 4 gallons per minute.
Okay, perfect. And then water's flowing out of tank?
Yeah, the resulting mixture is drained out at 2 gallons per minute.
Okay.
Find the quantity of salt in the tank as it's about to overflow.
Okay.
So 50 minutes.
Okay, so first things first. One of these questions is easy and the other one is hard. The first obvious question is how much salt is there in the tank, right?
Mm-hmm.
Easy question or hard question?
Easy.
Yeah, medium.
Well,
I have to set up a differential equation and solve it, right?
Yeah.
well, it's the start plus the intake minus the outflow. So gas.
I mean, so at least there's math, right?
Yeah.
Okay. Assuming we were scared of math, that would be hard. Easy question. When does the tank overflow?
50 minutes.
At 200 gallons, which is in
50 minutes.
50 minutes. You guys all with me on that? So at the end, I may as well think of the end is at t is 50. Right?
Well, why would it be 50 if it's also draining out at 2 gallons per minute?
It's going in at 4 gallons a minute.
So it's going in at 4 gallons a minute and going out at 2 gallons a minute. So that's a net gain of 2 gallons per minute.
Okay.
Right?
Yeah.
And it's got 100 gallons worth of space in it. Right? So all told, it's going to take me 50 minutes to fill up the empty space. That's cool, huh? Okay. So now I want to write a differential equation for what was the fundamental rule for tanks? There are 2 fundamental rules for compartments. What are they?
Don't model concentration.
Don't try to model concentration. That would be idiotic. And
It's always
Well mixed.
yeah, the rate of change of the amount in the tank is the rate out minus the rate in. Wait, no, the rate in minus the rate out.
And assume well mixed.
And assume that it's well mixed, because otherwise we'll have to do a really hard fluid dynamics problem.
Oh boy.
Okay, so don't.
That's later in the semester for me, I think.
No. No, we will never assume anything but well mixed in this class, because math is hard.
He will in the class though.
We might do it in 5C.
Yeah, maybe in physics land. Okay, so dq dt is, what's your rate in? What's the rate at which you're adding salt to this thing? Here.
1 pound.
4 gallons per minute, right?
And a quarter pound per gallon.
So gallons per minute at 1/4 pound per gallon. Cool, gallons cancel out. Now I'm in pounds per minute. That's good, that's what we should be in for dq dt.
Cancel out.
And then how much are we taking out of the tank?
2 gallons a minute.
2 gallons a minute. Oh, and then we need a pounds per gallon, right? So whatever goes here better be in pounds per gallon.
So, yeah, Q over
Yeah, so Q is the total amount, right?
100 plus 2T.
So we need Q of T divided by, by the amount of water in the tank, right? Or the amount of mix in the tank, at least. So that'd be 100
Plus 2T.
plus twice the number of minutes that have passed. Right? Because you get 2 new gallons for every minute that's passed. Okay, so all told here, I think that's 1 minus
Q over 50 plus T.
Yeah.
Q over 50 plus T. Okay, cool. And that's dq dt, right? Kz's? How do you solve such a thing?
Add Q over 50 plus T to both sides, knocking out the one on the right side, and then solve this normal differential equation.
So get to q dt plus q over 50 plus t is 1. And then solve per first order linear non-homogeneous. Cool, that'll work. Sometimes you get lucky when you're doing these tank problems. When do you get lucky doing tank problems? Like, when are these easier to solve? Yeah, when the rate in and the rate out are equal, because then you have a separable equation, right? Okay, well, crap. I tried. Here was hoping. All right, so if I want to solve this, how do you solve these?
Solve the homogeneous equation.
Okay, solve the homogeneous equation. So your homogeneous solution should be e to the minus
Integral of 1 over 50 plus T.
integral of 1 over 50 plus t dt. And I've set the constant of integration equal to 1 here, right? Or at least, sorry, not the constant of integration, but the other thing. I'm just going to drop that constant when I get there. Okay, so how do you integrate 1 over 50 plus t? U sub? Okay, so you let u be 50 plus t. So du then is 1 dt. Okay, so you get yh is e to the minus integral of 1 over u du.
Which becomes e to the minus integral of natural log of u, which becomes e to the minus natural log of 50.
Perfect. Which then becomes 1 over 50 plus 2. That's weird.
Well, you move the minus sign inside the ln and then use the ln something to something.
Yeah, it just seems strange that I got the same thing I started with, right? You guys see that?
Yeah.
Because that seems weird, if I differentiate this, I get minus 1 over this thing squared, right? If I divide this thing by itself, I get 1 over 50 plus t squared. Oh yeah, they're off by a minus sign. If I add them together, I get 0. Cool. Neat. It was weird, but it worked. It was right answer. How do I get it equal to 1?
Well, q is equal to the homogeneous solution times the integral of whatever's on the right side as a function of t divided by the homogeneous solution.
You remember that form?
Absolutely.
Cool. I don't. Okay, so I'm going to guess, right? I'm going to guess q is mu y h, right? And so then I'm going to plug this in there. And the homogeneous bit's going to drop off, right? So what am I going to get out of this? I think I'm going to get mu prime yh is 1. Right? So mu prime is 1 over yh. And now I think I've redeveloped that formula again. Yeah, cool. So mu is going to be the integral of 1 over 1 over 50 plus t dt. Yes. Which is going to get
plus 50t plus c.
times YH. So I think I get mu is the integral of 50 plus t dt. Yeah?
Yeah.
Okay, so I get 50t plus t squared over 2 and plus a constant. And then what's q?
Q is that times that.
That times that. Good answer. So that would be 1 over 50 plus t times t times 50 plus t over 2. Oh crap, I was hoping something would cancel this.
Still can.
Still can. What?
It's kind of odd, but you have, never mind.
No, I think
It's not gonna work.
Could you just distribute it? Oh, never mind.
sure, yeah, you can
Yeah,
distribute this stuff. Whatever. Up to algebraic rearrangement, you have this. I erased my initial problem. What do I need to do here? So now I found q, right?
Should plug in t equals 0 and try to get your initial.
Yeah, I need to make this fit the initial condition, right? Because so far I haven't used that information. So what was q of 0 supposed to be?
20, wasn't
What did they tell me at the beginning?
20 pounds.
20 pounds? Okay, so if I plug 0 in here, I get 1 over 50, that part's 0,
Plus c.
times c.
Times c, yeah.
So I think I got that equals 20.
So
So that seems like c is 1,000. Okay. Good. Now,
so now we evaluated 50 minutes.
yeah, now we want to know what happens as it's, yeah, so this is a weird thing. I really should be thinking, like, instead of taking q of 50, really I should take the limit as q goes to 50.
Yeah.
Sorry, the limit of q as t goes to 50, right? But q's probably a continuous function at 50. Slash, looking at it, q is actually a continuous function at 50, right? Because I didn't have to use the maximum capacity of that tank anywhere in this to solve it. It doesn't actually make any sense for me to say that this is the solution at t is 50, because it's not. Because anywhere past t is 50, this tank isn't following the system that I set up to solve,
Yeah.
right? The differential equation changes categorically at t is 50. Then instead of flowing in at 4 and outflowing at 2, it's going to flow in at 4 and overflow. Like outflow at 2 and overflow by 2. You guys see that? So there's what's called a bifurcation, like a change of categorical behavior. In other words, my differential equation no longer works at t is 50. But I'm just going to play dumb and plug it in anyway, because that's how I feel like rolling today. So really we should be thinking the limit t tends to 50, but same thing. Is what? I got 1 over 100, 50 plus, whoops, times 50 times 75 plus 1,000. Gross? I don't know. Seems like kind of a reasonable number. Equals number.
Pound.
Oh crap, I was using pounds. And because I was asked a word problem, I should probably answer like a human being.
There is this number.
And because it's a model of a real world thing, I should probably hedge my bets a little bit and say that it's about this. Right?
Allowing for variation in the actual mix.
I think 47 pounds.
Yeah. Did you get your guys' hang up? Where were you hung up?
I'm just not very good with these. I kind of really didn't know where to start, so I wanted to see when
Yeah, no problem. So start with the two fundamentals. Don't model the concentration, and the rate of change of the amount is the rate in minus the rate out. That will always get you started at least. And then it should always end up in a differential equation that you can solve. The other thing worth noting is this thing about, well, if the tank's filling up or draining out, then the concentration out is going to be the amount divided by some kind of variable. And that's when you'll be in this first order case as opposed to the like really easy separable case. Anything else on this one? Units all match up? Cool.